Assalamualaikum warahmatullahi wabarakatuh. My name is Shazlinda binti Halim and this is my partner Sabrina binti Abdul Halim. Today we would like to present to you the title of Stepping Motor Sizing and Selection DMK 40132 Power Electronic Session May October 2021. We are from class DMK 4A. Alright, this is our subtopic for stepping motor sizing selection. And the first is process involved in stepping motor selection. Second is details of the selection process, lead screw system. For the third is details of the selection process, belt and pulley system. And the fourth is the details of the selection process, which is gear system. Turn to subtopic first, which is process involved in stepping motor selection. Step 1. Decide on a mechanism and specification, which is step 1 is ball, screw, pulley and belt, linear slide. And step 2 is calculate the necessary drive resolution, which is find out what drive resolution is necessary for the motor. And then step 3 is decide on a drive pattern or motion profile, which is decide on a drive pattern that can satisfy the requirement. And then to calculate load torque and acceleration torque. Next is a tentative selection of a motor from necessary torque. Then decide to use motor based on speed torque characteristic. The last one is confirm the ratio of acceleration and deceleration rate and inertia.
Details of the selection process, lead screw system. There are 5-step selection process, lead screw system. Step 1. Determining the force acting on the lead screw. Step 1 involves determining the loads on the lead screw by using the weight of the assembly to be moved by the lead screw, the linear bearing type, the velocity, and the desired acceleration. It is important to know what kind of loads will apply to the lead screw to check for column strength issues. Also, you will able to use these loads with your lead screw selection to calculate required torque. The formula for the total lead screw force should be calculated manual as follows. Ft equal to Fa plus Fe plus Ff. The most substantial of the lead screw force is the acceleration force. So let's calculate that first. See the formula below. Fa equal to A divided by 12, W divided by G. Step 2. Find minimum diameter of lead screw. First, use calculator to find the smallest diameter lead screw that will work for your application. Use the total load that was calculated above. It should be noted that this calculator will provide the absolute smallest minor diameter of a lead screw that will be safe given the span and end facility type. You will need to find the close fractional size offered by your desired manufacturer. You may also use the column strength calculator if you have pre-selected a diameter and span and need to check if the column strength is more than the applied load. Critical speed. Refer to the RPM at which the natural frequency of a rotating shaft begins. The vibration, also called resonance, will occur regardless to the orientation of the lead screw. The critical speed also applies to rotating nuts about a lead screw. Given that CS equal to N multiply 4.76 multiply 10 multiply D divided by L2. For column strength refers to the maximum load of lead screw can withstand in compression before filing. Compression loads that exceed the column strength will cause the lead screw to buckle or bend. Even the slightest bend can ruin a lead screw. Given that Ci equal to N multiply 14.03 multiply 10 and multiply D divided by L2. Step 3. Selecting lead. Major diameter. The major diameter, also referred to as the length or outside diameter, is the outermost diameter of the lead screw. For a half minus 10 lead screw, the major diameter would be 0.5 inches normally. Second, pitch. The pitch of the lead screw is the linear distance between the threads. Third, lead. Lead is the linear distance the nut travels and the lead screw for every 1 revolution. The lead is equal to the pitch times the number of studs. Minor diameter. The minor diameter or the root diameter of a lead screw is the innermost diameter of the lead screw. The minor diameter is the diameter of the lead screw between the threads. Step 4. Check critical speed. Now you use the linear speed calculator to see the maximum RPM. Use the RPM value to place into the critical speed calculator by side. For calculator critical speed, use the critical speed calculator to see if the given lead screw's diameter and length allows for sufficient RPM of the lead screw. If the critical speed is higher than the operational RPM, choose a larger number, shorten the lead screw, or choosing a higher lead. Step 5. Reiterate through the steps. First, run through this step a few times to try and choose the best solution for your rotor. Second, oftentimes we must compromise on what we want to meet our budget or what is available. Third, however, use this tool to help make sense of the numbers. Fourth, play around with a City type, diameter, lead, and other attributes to see how it changed the cost of your setup. The last one is you can often treat attributes and still reach a similar outcome.
Details of the selection process belt and pulley system. There is 6 steps of selection process for belt and pulley system. For step 1, decide on a drive mechanism. This is the figure of the mechanism, which is belt and pulley system. Step 2, we find out to calculate the necessary resolution, which is the specification need is distance per move, position resolution, and the last one is pulley diameter. And the calculation, we find out the step angle selection based on Sanyo Denki company from Japan. And the use step angle, we find out the 0.9 degrees or step for the formula. And the last one answer is for position resolution will be answer 0.039 centimeter. For step 3, decide on drive pattern or motion profile, which is let T latest equal to T older over 4, which then speed F equal to A over T older minus 2 T latest will be on her answer, and A equal to total angular displacement, and A equal to total number of pulses. Then the specification need will be distance per move, position resolution, and the last one is positioning time. And the calculation will be number of pulses required, and the last one answer will be F equal to 480 Hz. For step 4, we find out the calculation of the necessary torque, which is the specification need is work and table weight, light friction, police diameter, police width, and position resolution, police diameter, and the last one is material of police iron. And the calculation will be find out the load torque, accelerating torque, and the total load inertia, and the last one is necessary torque. Step 5 is decide on a motor, which is the requirement is tap angle F and TM. Reference of Sanyo Denki stepping motor catalog sample given on page 24/25. Possible model choice are model number are given like this, and the rotor inertia J0 for all of the above model are the same at J theta equal to 57 grams centimeter square or 0.057 kilogram centimeter square. The stepping motor torque required is therefore Tm equal to 0.06 in the bracket of 0.057 plus 0.66 equal to 0.66 kilogram centimeter, which is in the bracket 0.067 Newton meter. So the last step is confirm the selection of the motor. If the only available power supply in a system were 12 volt, the preferred stepping motor from Sanyo Denki will be the model of 103G7751342.
Details of the selection process is gear system. Selection process gear system have 6 steps. Step 1. Decide on a drive mechanism. This is gear system. And specification, distance per move, position resolution, gear 1 diameter, gear 2 diameter, gear ratio, radius equal to 7.2. Step 2. Calculate the necessary resolution. Calculation. Step angle with respect to gear 1. Selection based on Sanyo Denki. Use step angle. Step 3. Decide on drive pattern or motion profile. Choosing a trapezoidal motion profile. Speed. F equal to A divided by T0 minus T1 equal to Hz. A total angular displacement equal to total number of poles. T1 equal to T0 divided by 4. Specification. V equal to 0.21 kilogram. A. Distance per move. Theta equal to 30. B. Position resolution. Theta equal to 0.25 divided by step. C. Positioning time. T0 equal to 0.4 second. Calculation. Total pulse count. A equal to D divided by theta equal to 30 divided by 0.25 equal 120 pulse. E. Let T1 equal to 0.25 multiply to 0 equal to 0.1 second. F equal to 400 Hz. For step 4, calculation of the necessary torque. Specification. A. Gear 1 diameter. 2. Gear 2 diameter. C. Gear 1 weight. D. Gear 2 weight. E. Table diameter. F. Material of table aluminium. Specific gravity P equal to 2.8 multiply 10 minus 3. G. Gear efficiency. N equal to 0.9. H. Gear ratio. Radius equal to 7.2. I. Thickness of table. Position resolution. K. Positioning time. T equal to 0.4 second. For calculation, first acceleration torque. TA. Inertia of gear 1 J1 equal to W1 multiply 1 divided by 8 equal 15 multiply 1.1 divided by 8 equal to 2.27 kilogram cm. Inertia of second, inertia of gear 2. Third, inertia of table. Fourth, total load inertia. Fifth, TA equal to JTA. Sixth, necessary torque. TM equal to TA multiply safety factor 2. Step 5. Divide on a motor. Requirements: A. Step angle equal to 1.8 divide by step. B. F equal to 400 Hz. C. TM 0.26 J0 plus 0.74 kg. Choices. Possible model choice. D. Model number 103G775 minus 1342. E. Model number 103G775 minus 2140. F. Model number 103G775 equal to 1242. G. Model number 103G775 minus 2340. H. Model number 103 minus 775 minus 6. I. Model number 103 minus 775 minus 324. For the last step is step 6. Confirm the selection of the motor. Stepping motor model 103 minus 770 minus 3240 from Sayo Denki. If the motor torque is required throughout the operation of the stepping motor, including at the startup, the none of the models given in adequate, it may now be necessary to look at the stepping models. As example, a stepping motor 103G770 minus 1 having a torque speed characteristic curve as shown in above. Notice at 400 Hz, the motor torque is above 1 kg.
Thank you for lending your ear.